Hello, good morning, and welcome to the latest episode of the EDIAQI webinar series. You know how this goes. We always start with some nice housekeeping rules. So please turn off your camera and mute your microphone. This webinar session is being recorded, so if you don't want to be recorded, please do not turn on your camera and mute your microphone. Very, very important as well, just to make sure we have no interruptions whatsoever. Questions can be asked at any point during the webinar. So please just ask your questions, put them in the chat so we can build up a really nice list of questions for our audience when we come to the audience section. The presentations will be shared after this webinar. And if you like captions, please click on captions, more, and then language and speech, where you'll find an option to turn on live captions. We breathe approximately 10,000 to 12,000 liters of air every day. And for most people in Europe, over 90% of that air is inhaled indoors. Yet this air can contain a complex mixture of pollutants, including particulate matter, volatile organic compounds, and biological contaminants, all of which are associated with significant health risks, particularly for children. The evidence is clear. Poor indoor air quality contributes to respiratory diseases, cognitive impacts, and long-term health conditions. At the same time, the economic burden is substantial, with estimates suggesting that air pollution costs the EU hundreds of billions of euros annually in healthcare expenditure, lost productivity, and reduced well-being. However, encouragingly, awareness is rising. Across Europe, researchers and innovation projects are generating a wealth of new tools, data, and approaches from low-cost sensors and advanced monitoring platforms to behavioral insights and policy-relevant guidelines. These developments present a unique opportunity to deliver not only health and environmental benefits, but also economic value and more effective public decision-making. Yet a persistent challenge remains. Innovation doesn't automatically translate into impact. Too often, promising pilots remain confined to project life cycles. Technologies are not scaled, data is underutilized, and insights fail to inform policy or practice at a level required to drive systemic change. In this context, the EDIAQI project is convening, a member of the IDEAL cluster is convening this webinar to explore how IAQ interventions can move from concept to lasting change. This session will address three central challenges. What IAQ pilot results and innovations have the greatest potential for real-world impact? How can we ensure that the results are effectively taken up, scaled, and translated into sustained societal benefit? Which practical examples from the IDEAL cluster projects, such as the EDIAQI's user-friendly solutions, including the AQB, best illustrate how integrated approaches across data, science, technology, and policy can be leveraged for scalable real-world impact? So, joining me for today for this discussion, I'm proud and honored to introduce our outstanding panel for today's latest installment in the EDIAQI webinar series. Starting from the left, we have Aset Kumar Mishra, Research Fellow at University College Cork, Ivan Nortadanato, Associate Professor from the University of Malasis, and Andrea Cuesta, from Leipzig, a researcher from Leipzig Institute for Tropospheric Research. So a quick run through of the agenda, and then we're going to jump right in. So we've done the welcome and introduction. Now we'll be heading to from determinants to decisions, leveraging IAQ data for real-world impact asset. Then we'll head to user-friendly IAQ monitoring as a tool to ensure well-being and comfort with Ivan. Then we'll head to high-resolution insights, unlocking the potential of IAQ sensing platforms with Andrea. And then finally, we'll go to the panel discussion. And then finally, we'll go to the interactive dialogue and questions from the audience. Please ask questions. This is interactive, and we really want to hear your thoughts and perspective. And finally, we'll head to concluding remarks from me. So without further ado, the floor is yours. Aset, please take it away.
Thanks, Alex and Seb. Hello, everyone. Good morning, good afternoon, or good evening, depending on where we are joining from. And it's nice to get this opportunity to talk. And Alex, can I forward the slides or do? Okay. So the topic is from determinants to decisions, and about leveraging IAQ data for real-world impact. This is something that I have worked with for past few years. It's specifically about raising awareness and how that can lead to better choices, modification in behavior, modification in policy, and yeah. So the way I can think of it, it's about moving, like you need to have evidence of something, or you need to measure something before you start to control it, start to legislate about it, or start to make changes. Without that evidence, you do not have awareness. Without that awareness, the occupants do not have an agency, and without an occupant agency, you are not going to see any changes in terms of actions or policy. So if you want people to care about indoor air, which they're 24 hours a day, you're surrounded by indoor air, but you don't see it. So you need to make people see what's in the air. Sorry. So as Alex started off saying that we breathe in about 10,000 to 12,000 liters of air every day, and about 8 to 9,000 liters of that will be indoors. Imagine this, like 8 to 9,000 sounds very large, right? But you, in an average day, you will be drinking about what, 3 liters of water, maybe consuming about 2 liters of food. Now, 8,000 liters of air, that's like 16,000 bottles of, like if you think in terms of supermarket bottles of water, that's what we are breathing in every day, but we barely care about what's in that air. Right? We would be very careful. Like if I handed over to you a opened, half-consumed bottle of water, I'm sure no one here is going to drink from that bottle of water, right? Because you'll check what's in there. But for air, it's kind of an invisible risk. And that's why, like, if it's out of sight, it's out of mind, you're not bothered about it. That's where this idea of monitoring in air quality comes in, because that makes the evidence visible. And once you have a visible evidence in front of you, once you see that, okay, this is how much is the CO2 level in the air, which means my ventilation is not too good, or I am working 8 hours a day in an office space where the temperature that is too much, this shouldn't be, or the humidity is too much, maybe that's promoting mold. So then that leads me to believe that, okay, I need to make changes. That's where practical decision making comes in. So data matters to people. I mean, yeah, data matters to us as researchers. We can publish some fancy stuff, get to nice conferences, and that's all well and good. But at the end of the day, data should matter to people. And this is also something that I've been trying to work on by making data gathered through different air quality monitors more accessible using open source coding and open source apps that just help you visualize the data that you've collected, because data helps you understand that what changed and when. Like if you see that at a certain time every day the temperature in your bedroom is going up, then you might think, okay, what's going on? Like maybe there's a heater or something that turns up at that particular hour because I set it like maybe a few months ago, maybe during winter, and then I forgot about it during summer. So that guides your behavior. Then that behavior changes can lead to actions, and it also gives you a voice. Like let's say if you were able to check the air quality in your office space. Now in Ireland, so the health and safety authority, they have this code of practice related to indoor air quality. And if you frequently see that the CO2 levels in your office space are over 1,000, then you can voice your concerns to your employer. That see, these levels are not in line with what the code of practice from HSA says. So we need to take some action. So that gives you a voice based on the data that you have gathered, and that then leads to policy changes. Because so I remember that during the pandemic, there was a lot of grassroots level awareness, which was leading to collection of data in different spaces, and that subsequently led to legislations in Ireland and Belgium, which led to changes that meant that air quality in public spaces, like public indoor spaces, need to be regulated, and there need to be a display of air quality related information in the spaces, and that gives you agency change policy. For me, this is specifically related to the work that I do with schools. And so I'm talking about going to a classroom and then talking to the students about air quality, about thermal comfort. So basically what we call the indoor climate. So in general, if I went into a space and just did kind of a survey, then that IAQ data or the indoor climate data would help me diagnose what kind of issues are there, what kind of changes can be made by the building management, what kind of additional agency could be provided to the occupants. When I'm doing the same thing in the schools, I like to be a bit more involved so that you have this opportunity to kind of go there, talk to the teachers, talk to the students about what we do as researchers related to indoor air quality, and why are we taking these measurements, what do they mean for them, what do they mean in terms of their health, in terms of like their ability to learn, because poor ventilation affects learning as well. And then we have an opportunity there to kind of get them involved in this process, that it's not something that it's not kind of helicopter research that you go in, you take some measurements and get out. You go in there, you talk to them, you get them involved. So it kind of makes classrooms living labs, and making the whatever you're doing there, get that kind of interlinks with the STEM agenda of the school itself. So that's easier to get the cooperation of the school and the teachers with. And then you can talk about, like, this isn't just about air quality. It also relates to aspects related to climate change, building design. And because there's a huge volume of data, you can even turn in that, okay, we use AI or machine learning to make sense of this large volumes of data. So that's a kind of intricate linkage with the STEM stream of the school. And then this is something important because we always regard children as our future sustainability leaders. So awareness should start early. So IAQ data is not just about diagnosing, not just about taking readings. It can also help educate, empower, and change culture in the longer run. Now, just a bit about what makes data usable. Like, I can give you examples of tons of projects where data has been gathered and then it hasn't been used, or it has been used in a very limited way. So if you have clear data about the data, so that's called metadata, and then it's interoperability means, like, there's a clear idea of what data was collected, in what format, and it's available. And then that helps us to reuse the data to make more analysis and leads to more actionable output than if you just do a study and keep the data in your own laptop and forget about it. So today's discussion will later, like, I will later touch upon this point. So that's about uh, available data, open science, and evidence and policy. So this is something that we'll discuss, some of the aspects that we'll discuss later. And yeah, Alex, I think we can move on from this. So just as a closing thought for everyone, for lasting change related to indoor air quality or indoor climate, we need monitoring, but we do need monitoring that people can understand and data that multiple groups can reuse, and evidence that institutions will have to act upon. So it's about turning evidence into agency, turning agency into healthier living spaces. And just as a closing remark, I had a question for the panel as well. How do we move from successful IAQ pilots to systems that people trust, institutions maintain, and policymakers can scale? So this is something that I have also struggled with. So I have some ideas, but hope, like even from within the audience, if you have comments, if you have ideas of how it would be easier for people to adapt to these ideas or adapt to whatever is developed in a lab into their lives, feel free to let us know. Thank you so much.
Thank you so much, Asset, for that very nice overarching look at using evidence for data, especially within indoor air quality. This is obviously something that's absolutely key. I much appreciated the comparison with water. I love to always mention as well that, if you go back to the 1800s in the United Kingdom, they used to actually drink like something that was like a beer, like a light beer, basically, because the water was so toxic that they couldn't drink the water. I mean, this was in London, I believe. So just it was called gruel or grol, if I'm not mistaken, something like that. But I'll find out after this. But just the point to say that the water was so bad that it was undrinkable, right? And now we've completely reversed that, where we're living in where we put such a focus on clean water, right? So I think it's a really important parable, and of course, just to echo you on the agency of children, right? And I really love that. I'd never thought about that before, that you're also changing culture when you're getting children involved in the process. So lots of food for thought there. Thank you very much for sharing. And I'm going to make a shout out to the audience. Asset has asked a question to you. Please do answer. Please do your comments. How do we move from successful IAQ pilots to systems that people trust, institutions maintain, and policymakers can scale? We'd love to hear your views and comments, and then we'll discuss them in the audience section. Okay, thank you, Asset. Let's head now to Ivan Notodonato for user-friendly IAQ monitoring as a tool to ensure well-being and comfort. The floor is yours, Ivan. Take it away.
Thank you, Alex. Good morning, everyone. I would like to thank Alex for the introduction and all of you for being here. In this presentation, I will outline the main features of instrumentation and share some experimental results obtained from monitoring IAQ across different types of residential environments. The results I will present refer to the Ferrara pilot, part of the EDIAQI project. The monitoring was carried out using both active and passive samplers, respectively NetPid and Radiello. Next slide, Alex, please. Thank you. The NetPid is a remote monitoring station equipped with a PID detector that allows the measurement of IAQ indicators such as CO, CO2, NO2, O3, TVOC, and PM2.5, as well as basic parameters like temperature, pressure, and relative humidity. The instrument is extremely easy to use and does not require specialized personnel. Among the main features of the NetPid are the high sensitivity. It performs measurements down to the ppb concentration, but the key feature is the remote control, which is particularly functional. Once connected to an internet network, the instrument acquires data and synchronizes in real time with an online platform that can be accessed from any device. Next slide, Alex, please. The NetPid performs a reading every 5 seconds, although this setting can be adjusted by the installer. The statistical indicator we typically work, which include the mean, standard deviation, or relative standard deviation, minimum and maximum values, and range of percentiles. These metrics allow us to identify potential anomalies related to the false instrumental readings. In the example, CO2 exhibits anomalous peak compared to the baseline level. The first step is to determine whether this is an isolated point, for example, an instrumental error, or part of Gaussian distribution, as in this case. Once we establish that there was an release event at the moment, we try to trace back the possible causes that generated the peak. Next, Alex, please. This histogram compares a selection of results obtained from the NetPID during a summer monitoring campaign. Two different public offices are considered. Within these buildings, 3 types of rooms were selected, labeled with room 1, room 2, and room 3, and represented by the colors blue, orange, and gray, respectively. These rooms were chosen to have a similar characteristics in terms of surface area, occupancy, and exposures. More specifically, room 1 is occupied by a single person, room 3 hosts multiple occupants, while room 2 is characterized by a window facing a road with heavy vehicular traffic. The data have been normalized, and the bars show the percentage contribution of each compounds to IAQ across the different room types. We observe that the contribution of the most analyzed compound remained fairly constant across the 3 rooms type. An exception is CO, which shows a significant contribution in room 2. This result highlights how IAQ is strongly influenced by outdoor atmospheric conditions, in this case most likely due to external vehicular traffic. Next, thank you. Here I present a comparison between summer and winter average values of the analyzed compound across 4 different types of buildings. The concentration of CO, CO2, O3, and PM2.5 all trend to increase when moving from the summer to the winter. In contrast, the NO2 concentration show a decreasing trend from summer to winter conditions. VOC concentration remain fairly comparable and very similar across all the environmental conditions and building type considered. Next, Alex. Passive sampling was instead carried out using the radiello. Radiello is composed of a support, a diffusive body, and a stainless steel mesh cylinder coated with a specific absorbent phase, which vary depending on the class of compounds to be analyzed. Unlike the NetPID, radiello not require electrical power and cannot be connected to any device. It also requires chemical desorption followed by analysis using chromatographic techniques, and therefore must be handled by specialized personnel. We use a radiello sampler for the determination of VOCs and aldehydic compounds. Next, Alex. All the molecules analyzed through the 2 passive sampling campaign are shown here. The VOCs were analyzed using ZCMS, while aldehydic compounds were analyzed using liquid chromatography, HPLC-DAD. It was possible to characterize 17 VOCs and 13 aldehydic compounds. VOCs were further classified into 3 categories according to their chemical structure properties: aliphatic compound, chlorinated compound, and aromatic compounds. Out of the 13 compounds analyzed, as many as 5 are included among the main IAQ markers according to the guideline provided by the World Health Organization. Moreover, when adding NO and CO, the number rises to 7 out of a total of 9 K markers. The analysis and interpretation of these compounds made it possible to identify and characterize different indoor air quality scenarios. This slide presents a comparison of benzene concentration across the different types of indoor environments that we are monitoring. On the right side of the histogram, the average outdoor benzene concentration is reported. The most significant finding concerns the different type of office. Office 1 is mainly influenced by car traffic. Office 2 is primarily affected by the passage of trucks, small excavators, and light-duty vehicles used for routine urban maintenance. In Office 3, only urban and intercity buses circulated. The analysis of the histogram suggests a clear hypothesis. Indoor benzene concentration is influenced by the type of the vehicular traffic. Greater combustion activity leads to higher benzene levels. In the school, benzene concentration are fairly similar, which will be approximately 3 times higher than the outdoor level. This suggests the presence of a common indoor emission source. The restaurant shows a benzene concentration about twice the outdoor value. This result is likely due to the presence of an open kitchen. The highest value recorded in the private house can be attributed to the intensive use of incense and scented candles by the occupants. In contrast, benzene concentration is particularly low in the gym's cardio rooms. Next, please. This slide presents a comparison of formaldehyde concentration across the different monitored indoor environments. Once again, formaldehyde concentration are higher in all public office compared to the other types of environments. This result is consistent with the specific configuration of the space, which contain numerous shelves and findings used for storing documents. It is well known that many varnishing materials can release formaldehyde, as it is commonly present in the resin and adhesive used in their production. Schools show formaldehyde concentration nearly twice as high of the outdoor value. Traditional school desks represent one of the main sources of the emission with classroom. The formaldehyde concentration detected in the gym is luckily related to the presence of numerous cardiovascular exercise machines, such as tapis roulant, stationary bikes, or steppers, and the presence of the parquet flooring. For the other environment, the same consideration mentioned earlier apply. I'm finished. Thank you for your attention. Thank you all.
Thank you very much, Ivan, for that deep dive into the work that we're doing at EDIAQI and Ferrara. You can see a lot of the complexity that's gone behind this and how difficult it is maybe to interpret it and make it accessible, right? But you've done just that, Ivan, and you've brought a lot of clarity and insight from a lot of complexity from the data. And maybe just one other side comment that I really appreciated the comment about the scented candles and those what are they called? They're sort of like it's always volatile organic compounds, some sort of like a scent spraying machine. My stepmother has 1 million of them in the house, now after this work, I remember it so much and I can just smell them so intensely. It might be placebo that I'm getting a headache when I'm smelling it, but I promise you, I swear I get a headache every time. So maybe, and I think somebody said at this, just because it smells nice doesn't mean it's actually good for you. And vice versa. Just because it smells bad doesn't mean that it's necessarily bad for you either. So thank you very much for that really interesting look at the work that we're doing. Now we're heading to Andrea, also from the EDIAQI project. Andrea, please, the floor is yours. Take it away.
Thank you, Alex. Good morning, everybody. Thank you for the introduction. So today I will talk about the importance of high-resolution indoor air quality measurements and the application of co-created middle-cost sensing platforms. Alex, can you? Yes, that's it. Thank you so much. So we know that indoor air pollution is extremely dynamic. It is influenced by indoor sources and activities such as cooking, cleaning, and occupancy. Consequently, the magnitude and the frequency of indoor pollutant emissions and concentrations will change during the day and can only be observed when we perform high-time resolution monitoring. On the other hand, we have also that outdoor air pollution infiltrates into indoor spaces and contribute to indoor pollution levels, which is also depending on the building material. So given the heterogeneous spatial variation in outdoor pollution and building materials, the indoor concentrations will also change depending on the geographical location of the indoor space we are evaluated. Therefore, to understand and measure indoor air pollutants, we need an approach that combines both a high temporal and a spatial resolution. Next one. Within EDIAQI, we have worked to achieve two big goals. First, we always try to develop and use novel indoor air quality monitoring solutions, such as the one my colleague Ivan just described, and do this involving the participation of stakeholders. We are also aiming to evaluate aerosol particle exposure and health effect in children. For this, we have considered the feedback that we have collected in different pilots and campaigns that were developed in the beginning and along the project. And we have also collected valuable information through surveys dedicated to the general public and to the technical participants. And from this feedback, we have created a dual strategy to tackle these main goals, which consist into first performing novel indoor air high-resolution measurements for exposure to fine particles. And these measurements has to be done considering that they can be operated, for example, via touch screens buttons. They should be interactive and portable. And this is one of the main recommendations we got from the general public. Combined to the measurements, we also look to perform evaluation of the deposition of the particles in the lungs. And for that, we decided to do modeling, which is a powerful tool that allows us to do evaluation with non-invasive methodologies. Next one. With this in mind, Tropos and EDIAQI developed a novel and non-invasive device, which is called AQB, and stands for Air Quality Beacon and Emission Evaluator. The AQB is a small box that you can see in the image. Maybe if you see me in the camera, I have a small box here with me so you can see the size. And it combines low and middle cost sensors to measure particle number size distributions and to determine the mass concentrations of particulate matter in different fractions. The device also measures CO2 and the indexes for VOCs and NOx weather variables, and it can detect the presence of people in the room. One of the most interesting characteristics of the AQB is that it is kid-friendly. It has a very robust design. It is interactive. It is portable and can be operated with a battery that lasts approximately 18 hours. It is also very silent. And this is also one of the most important feedback we receive from people when we did the surveys. So it can be operating in a room during the whole day, during the whole night, and people will not even notice it. The collection, which is the data collection, which is also an important characteristic of the AQB, is done in a dual strategy or approach. So first, the device has a local SD card that is storing data continuously, but the data are also transmitted using an IoT approach to servers are Tropos, so we can, as researchers, see the data in real time and also do evaluation and corrections if needed. Next, Alex. So in the main screen, Alex, can you please display the video? In the main screen of the AQV, you have several characteristics. So we thought on creating a device that is easy to manage and to understand for the general public. So we can see the indoor air quality index, the contribution from different pollutants, the size distribution of particles, the weather variables, and it can also it gives us the opportunity, for example, to log different activities. So this is very important for researchers when we are measuring time series of pollutants. And if the users are engaged, we can actually observe when a specific peak or a specific concentration is associated with a specific activity. Thank you, Alex.
Bear maybe 1 second so I get the presentation up here. We had a few little technical difficulties today with integration.
No problem.
2 seconds.
Thank you so much. And we use AQBs in a campaign in Zagreb. So it's the first campaign we conducted using the devices. We measure indoor concentration in 15 households during 2.5 months. And we also compare our indoor data with outdoor air quality data from reference monitoring stations. Next one. And this is one of the preliminary results we have so far. In this time series, you can see the temporal variation in PM2.5 concentrations that were measured across all households in Zagreb, except for 2 households where we had to exclude data because they had particularly high concentrations arising from specific sources, which affected the global statistics. So you are seeing here results for 13 households. Each one of the boxes you can see corresponds to 1 calendar day of measurements and includes hourly averages from the AQBs. The dashed horizontal lines that you see are the regulatory limits from the European Union, the World Health Organization, and the GO-AQS initiative. The dark blue line that you can see that is connecting the boxes represents the median concentrations for all households, and the black line, which is dashed on top, is the average outdoor concentration. So we can clearly see at a first glance that indoor or the median indoor concentrations follow a trend from outdoor pollution. This comparison led us to estimate an average penetration factor for Zagreb of 0.3, so around 30% of outdoor pollution comes indoors. Furthermore, we can observe that there are several outliers. So these dots on top of the boxes are believed to be the contribution of specific sources, such as cooking, for example. Because in indoor spaces, we have most of the time basic or background concentrations, and then we have different events or activities that will contribute and increase the concentrations during a specific and usually short periods of time. So most of the outliers that we observe in this image are related with specific activities, in most of the cases, cooking. Next slide, please. So this time series, I have two time series here, one in the back, which is for a specific household. So I'm zooming here now to one household. And we have the dark blue line, which is the PM2.5 concentration measured by the AQB. And then we have a light blue line, which represents the PM2.5 concentration from the outdoor monitoring stations. Considering these specific households, we could estimate a penetration factor of 0.26. And when scaling the outdoor pollution with the penetration factor, we have a normalized outdoor contribution to this specific case. So you can see in the main time series that is a bit bigger, how the change in the indoor activities, which were usually cooking in this household, is clearly visible, the contribution from this specific activity and the comparison with outdoors. So those are the three peaks you see highlighted in red. But also in the middle of the time series, there are some small peaks as well. And those peaks are mostly associated to contribution from outdoor pollution, because they follow the trend and they are much smaller in magnitude. Next one. We have some very preliminary results from the lung deposition modeling. We took the data from the campaign in Zagreb and used a model to determine how many particles can deposit in several regions of the lungs. And in this specific case, I'm showing the deposition in the alveoli region, considering a 10 years old kid who's sitting or doing mild activities. What we can observe from the modeling results is that around, for example, 20% of particles in the range of 1.5 micrometers will be deposited in the alveoli of the children when doing mild activities. But this is a very powerful tool that helps us to understand, for example, what is the contribution of different sources, and from those sources, how much of those particles can deposit. Next one. And finally, I would just quickly like to mention that at Tropos, we are performing intense data and quality analysis of the AQBs. We want to make sure the devices are comparable and trustable. So it's important for us to guarantee that we have data that are closest to the reference instruments, because this is not a reference device, but we are using these devices for research. So we are comparing how much the devices can detect using different sources, as dust from vacuum cleaners or reference dust from different cooking activities like frying, or from ambient air concentrations, incense, ethanol, and CO2. So we are attempting to reproduce as much as possible real conditions and determine the precision and the accuracy of the instruments. So far, we have seen very good results. The devices are very close to the reference instruments, and they are also showing high precision, so high comparability within them. With this, I would like to just briefly summarize that we have observed that indoor air pollution is not only a problem related to a specific household, but is also related to urban patterns. Outdoor air pollution has a significant influence on the particle matter concentrations that we characterize in Zagreb households, and sporadic sources can contribute to higher exposure peaks. The next steps we want to do are perform further laboratory characterization and evaluate the data. We want to continue with the evaluation of the field data, which is also going on. We, of course, will continue working in the lung deposition modeling, and we expect to use the AQV to evaluate indoor air pollution in other cities and environments. Many thanks.
Thank you, Andrea, for that deep dive into this really cool sense. I mean, I'm calling it cool. It's much more than cool, but I think it's something really special as well, the focus on children. Obviously, a lot of the ideal cluster projects and us at EDIAQI are really focused on empowering children to be able to take as much agency and ownership of their indoor air quality as they can. I would like to highlight something else, which is really cool, that it's silent. That was one of the observations that we actually got from some of our studies, right? When they used the high-end equipment, some of the parents actually put the sensor in the living room, if I'm not mistaken, because the children weren't able to sleep at night. I have 2 children of my own, so I very much empathize with these parents as well. And I think it's these kinds of observations as well, which are really critical for further studies, right? So that we can make them as accessible as possible. Okay, so we're heading now to our panel discussion. I invite all of our panelists, speakers, to please turn on their cameras. I'm going to be spotlighting you now, so you're in the spotlight. So Asset, Ivan, please, let us see you. We might have lost Asset and Ivan. Let us check this.
Yes, I am here.
Looking for the camera.
For Asset.
Hey, Alex.
But we'll all turn on the cameras now. Just imagining we're kind of like a virtual panel. So if I invite you to turn them on.
Sorry, did you want an off or on?
On, please, on. I would love to see. Okay. But we can ask with the camera off for the time being. I guess maybe you're having some difficulties there turning on the camera. So Asset, how can fair data and open science approaches support long-term uptake and reuse of IAQ results?
I guess I touched a little bit upon this while I was talking initially, and it's important to understand that during any given study or research project, we tend to gather a lot of data, and most of it is at the end of the project might not have been used. So there is a ton of data out there from different projects across last 3 decades. And in the coming decades, there is going to be more data because we now have more easily available sensors. We have IoT platforms which are collecting data. And what this leads to is that you have a lot of data which could be translated to evidence. But sometimes the person who is gathering the data may not have the time to work on them. Or sometimes what may happen is there are funding limitations, a project is drawing to a close, or it could be that, let's say someone at home, like Andrea discussed about the sensors being used at home, and then someone at home is using a monitor, but they don't really have the time to utilize the data or to kind of interpret the data. So this is where fair data practices like make the data findable and making it work for you and across multiple projects becomes important. And we not only share the data that we have gathered, but we also share information about how we gather the data, how do we process the data. And for certain user cases, like let's say for a home user, and this is something that I've been recently working on, like, so you have certain platforms online, open access, easily available, no one has to pay for them. So if I gave you the option that you could like kind of open a page, take the data that was gathered by your monitor, and just upload it into the page, and then that page gives you a nice report of how your home data was over the past week. It tells you about when over the day you typically have peaks, if there is difference between weekdays and weekends, if there is a pattern associated with a certain day of the week or pattern associated with a certain hour of a day. That's much more usable, right? So this is the kind of accessible forms for both the data, how to gather it, how to process it, and how to visualize it. These are kind of fair data and open science approaches that would help for turning data into information and evidence, as well as making sure it's taken up by wider sections of the society, that more people feel that they can use the data, more people feel that they don't just have a monitor, they can create something easy to understand, something easy to interpret, and something that they can take and go to their to some, like, let's say you can go to the person, your landlord, and say that, okay, this is what's looks wrong with my home data. Or you could go, like, if you're on the home, then you could tell a contractor that, okay, this seems odd, so maybe I should replace my filters in the kitchen hob extractor, or maybe I should get a new one. So that gives you the ability to make changes, make a difference with all the data that you have. Otherwise, it's just going to sit in some server somewhere and not going to be beneficial.
Thank you very much for that very interesting answer there, Asad. Fair data is, I think a lot of the ideal cluster, a lot of the Horizon projects always have a big focus on, and it's true. Sometimes that data sits on the server and isn't utilized, right? And it can do a lot for us. So big shout out there. And I like this, maybe this kind of sort of a layer thing, right? You could have this sort of solution, if you will, that could interpret the data for you and give you advice. I will give a shout out and a promotion to our simulator that we created, which is something we'll be sharing at the end of the project with this idea. I don't know if obviously as comprehensive as kind of the solution you were mentioning there as well. So very, very interesting stuff. Okay, now taking it to Ivan and building on top of that, how can IAQ monitoring solutions then remain both scientifically robust while also being user-friendly?
Okay, Alex. I think the use of low-cost sensor that can continuously monitor several indoor air quality parameters is a practical technological solution for improving how air is refreshed in indoor spaces. These devices record information that makes it possible to adopt more intelligent and efficient ventilation strategies. With this information, it becomes possible to adopt smarter and more efficient ventilation strategies. For example, mechanical ventilation system can be activated only when certain parameters exceed critical thresholds, or window and air vents can be adjusted automatically. This help avoid both insufficient air exchange and excessive ventilation, which would waste energy, especially when outdoor air needs to be heated or cooled. Moreover, integrating this sensor with building automation systems or IoT platform allow to the collection of data, making it easier to identify recurring patterns and further optimize system performance over time. This data-driven approach not only improves indoor air quality, but also reduces energy consumption and operating cost, making buildings more sustainable and efficient.
Thank you, Ivan, for a very big look. I think one of the things you kind of said there, and actually, Andrea mentioned him as well, Sotirius, because you mentioned the GoAQS, But one of the big things he said, because I was always about giving, giving impact, ensuring that we're empowering children, giving them knowledge, building on kind of what Asad said about the cultural change. But one of the things he told me is, yes, but we also want that data to do something like in IoT systems, for example, right? And then you're putting the onus on the children to have to, take action when you should have systems in place to do that. So it's a really important point as well, right? Is that we need systems to read this data and then to kind of make automated decisions on their own, right? Ones that they can make, for example, intelligent management systems. I always call them business building. And there's a question in the chat. Please ask questions, get ready, because we're coming to the audience section. And actually, we're going to ask you Asad's question again, and we're going to force an answer from you. So now, Andrea, building on top of what Ivan has noted about, making this robust, very complex data robust and actionable, right? How can systems support both scientific research as well as practical decision making?
Yes, I will follow the line from my colleague Ivan, and absolutely when we talk about the AQV and when we thought about the design of the instrument, we had two main focuses, and one was how this can be more user-friendly, so for the general public, and how then this instrument can also provide research-grade information. So with that in mind, the design of the AQV consider to be a very interactive and visual device, so we can engage with the people and they can actually help us to understand what their activities look like and how does this translated into data. So the system can support scientific research by the way, or it can do it from the beginning when we are thinking on the design of the device. And then when it's operating in the households, we can engage, or the people can easily engage with it to have insightful information for us scientists. In terms of scientific research, one important activity is to perform laboratory intercomparisons and calibrations, so we can actually see how reliable the data that we are measuring with the devices are and implement corrections if necessary. So I will say the high temporal resolution, the specific and well-thought design of the device, and the interaction with the general public can give enough information and the chance to be both scientifically and decision-making applicable. Also for decision-making, so when the people can actually see the air quality index or can actually see the concentrations in a way that is simple and understandable, they can directly understand what the impact of their decisions day-to-day life looks like in terms of concentrations. We need to make sure that the general public have data that are accessible and clear, and this is one of the main challenges as we as scientists have when raising awareness and involving and engaging with the general population.
I think anything that you can sort of play with, right, is always going to support. And I didn't actually know, because I've never seen this device in my hand, but I didn't realize how much there is to it, right? Like, I didn't realize you could, even the cooking activities that you're doing, for example. And I think it goes to what Asad said as well, right? About the culture change, which is quite interesting, right? We're giving, especially kids, right? That's the next generation there, right? We're giving them tools to interpret their surroundings, to interpret the pollution, and also understand the potential health effects. And that hopefully is going to raise awareness. I love the smoking example in the US. If you look at the US with smoking, they actually, they had very high levels of people who smoked. And now if you look at they actually have very, very low levels. In fact, you feel like a pariah almost smoking anywhere in the United States, because they force you into some sort of a corner. very often, right? And something they don't allow it in parks, for example. And a lot of that they attribute to strong campaigns, right? Strong public health campaigns. Now, so in many senses, this is a similar thing, right? We are promoting to children at a very early age this sort of an understanding. So thank you for that very interesting point. Okay, now we'll go back to Asset here a little bit. What is needed, Asset, to translate scientific evidence, so a lot of this evidence that Andrea was talking about, into effective IAQ standards and policy strategies? Please take it away.
Okay, I'm going to be frank and honest here. I have no idea. So there is, and this is in fact something that we're discussing in another forum of researchers as well as practitioners in the building science field yesterday. So the query was like, what is more effective? Is a top-down approach that you convince the policymakers or the lawmakers to, or the standards, like you have certain standards related to indoor environmental quality, you have certain standards related to exposure. So do you make changes in the standards or in the policies? Is that more effective, or is it more effective to have grassroots level awareness increase, and that would then effectively lead to changes in the standards and policies and strategies? Is a ground up approach better or a top down approach better? So ideally we should have both, that there is an increasing awareness amongst the users, amongst the people who are affected most, and that they influence the policymakers, the lawmakers, and that then leads to changes in policies and strategies. At the same time, it may not always work out in the most ideal or the utopian fashion where we have both sides of the argument. So we do need like evidence, building up the evidence base. So that's what research is about. But at the same time, researchers need to work with other stakeholders, work with the general public to raise the awareness. And like specifically for indoor air quality, we also need to work with the construction industry to make sure that things that we work on can be implemented in the ground. Like, think of this, there are several countries in the EU itself where there is a absolute you do not have enough experienced people in the construction industry to put in something like a mechanical ventilation system with heat recovery. And when you do not have enough experienced professionals, the price of that rises exponentially. And so if that's not a possibility for a person to put in such a ventilation system in their home, then that's not a feasible tool available to them to improve their home air quality. So that's also in the mix where we need to facilitate the training of the construction industry workers to make sure that they are able to put these things in place. And so there is a lot of investment in terms of how do we make homes more climate resilient. But that's right now, this is entirely in terms of how much your home is, how much energy is the home consuming, how much are the emissions associated with that. But in addition to that, we also need to bring in the angle of this is primarily a health and well-being aspect for the people living in those homes. And if we want to make sure that we can move towards effective IAQ standards and policy strategies, it has to be, I mean, ultimately, we have to move towards towards that utopian situation where we both have effective standards as well as awareness amongst people to be able to use the systems available in a way that can make sure that human behavior is not being counterproductive to the systems that have been put in place. Unless there is a cooperation and synergy between these two approaches, then it will often end up with us spending more energy, putting more people more at risk and higher exposures.
Thank you. One of the things super interesting I just want to pick up on there is the upskilling. Like in some senses, you're saying we need to upskill people in the construction industry, right, to be able to learn these new skills or understand these new and obviously I'm thinking about
If I
COVID here,
can
right?
take a minute
Yeah,
there,
go
Alex,
ahead.
I'll give you an example. So this often happens whenever there is a boom in construction industry. And so this happened in Ireland in about 2000. So there was a large uptick in the number of houses being built, but they did not have enough skilled practitioners. So what happened is if we like when we monitor houses from that period, we'll typically notice that the insulation is not very well done. The heating layout of the heating pipes, the radiators, that's not very well done. And so people who live there now, and often these will be now elderly people, so they are left more vulnerable because we did not have enough skilled personnel on the field. The standards were there. The standards asked for a certain level of insulation, and the people who were working on it, they did the best they could or whatever they knew. But because they weren't trained appropriately, then they have left in something called thermal bridging. So there is condensation, there is mold. The insulation doesn't work as well as it could. So these are the kind of situations that most often this will be faced by the most vulnerable population in the society. This does not happen to the well-off sections of the society.
And I think that's a magic word there for me as well. I think, when we describe poverty, for example, right? Like, what is poverty? And for me, I think that's a really good explanation. It's a lack of access to like a healthy environment, for example, right? Because you don't have the resources to be able to afford, the right building materials, for example, healthy building materials, all these kinds of a system, right? So there's a massive interconnection between all of these. And maybe I will give my answer. I say I agree with you on that. It's top down, bottom up. Maybe a light stick, because policy is sticks and carrots, right? So maybe a very light stick and lots of carrots, and maybe changing that around as we go into the future. And I think the European Performance of Buildings Directive, that Ireland is also succumbed to, like Malta, and all the rest of the EU, could be like a initiation of that. Okay, Ivan, please. Now, building on top of that, and thank you very much, Asif, for that very interesting and very poignant answer. Ivan, building on that, then what's needed to ensure the large scale adoption of all of these solutions, all of these technologies, of this data that we've been discussing today, in your view?
Good question, Alex. Very good question. I think that what needs to change is the overall approach to indoor air quality. It should be seen as a tool for improving well-being and quality of life. How do you say in the start of the webinar? Scientific evidence show that people spend on average about 18.5–19% of their time indoors, whether at home, at work, or in the other spaces included. This makes indoor air quality a key factor in overall well-being. Understanding this requires a broader perspective. Indoor environments are not just shelters, but ecosystems that directly influence physical health, cognitive performance, and emotional state. Long-term exposure to poor indoor air quality can lead to fatigue, reduced concentration, respiratory uses, and increased health risk. On the other hand, maintaining clean, well-ventilated indoor air helps improve comfort, productivity, and overall quality of life. Always scientific evidence shows that living in a healthy indoor environment also has a physiological dimension. When air quality is properly managed, occupants tend to feel more comfortable, which positively affect social interaction and overall mood.
I think one of the very important things as well that I want to pick up there is the perception thing. I went to a talk this week, and that was an interesting thing. Sometimes the pollution and the feeling might not necessarily 100% coincide, right? But perception is really key as well, right? So like the indoor air quality is absolutely critical, but so is things like humidity and comfort, right? And that these are really important things to factor in, and they will actually really support I think will support the adoption as well, right? Because everybody wants to live in a comfortable indoor environment, right? I mean, they also want to live in a healthy one, and they might not be able to understand that, but they will perceive, they will always perceive, right? And I think that's one of the really important things that, okay, thank you very much for that. Very nice.
Alex, if I
Yes,
may
yeah, of
take
course, sorry.
there. So drawing upon what you're just mentioning, so because I work both on thermal comfort and indoor air quality, so we know that human beings are really good at sensing the thermal environment. So we are like, even if the temperature changed by a degree or so, people who are sensitive will notice that. But in air quality, we are really bad. So most of the time, so like something like, let's say, benzene or formaldehyde, both of which are carcinogenic, the level or concentration at which we'll be able to smell them, that already exceeds the level at which their safe exposure limits.
Thank you, Asset, for it's a very important point. Like we can feel heat, we can feel cold, right? We can feel humidity, but it's hard and very difficult to, yeah, it's impossible to know. And this smelling good and smelling bad, because somebody told me that once, and I think that's a really good example. I like how we've gone a little bit more into this discussion here. Andrea, to close off the panel section, we have 2 questions for us coming up. And building on top of all of this, what role can these platforms play in raising awareness and supporting users?
Yes, so I think it's important to consider when we talk about improving indoor air quality, it's common to think, okay, we need to do very sophisticated interventions or technically demanding interventions. And I find very special that we should remember that an intervention is already making the people aware that indoor air quality is an important parameter, that it can affect their health and their well-being, and that it can be measured and that they can actually participate in those measurements. So the simple fact of bringing a sensor indoors into families who were not aware of indoor quality at all is already an important intervention that can contribute, ideally, to a different or a change in their mindset. So it's already a way to start creating awareness. Of course, it's not the only one, as my colleagues have already mentioned, and it can actually not be sustainable in the long term, but it's already a starting point. And we saw this when we did the campaign in Zagreb. Many of the families were quite curious and asking questions about the device and actually saying that they were not much aware of indoor air quality and how the different activities can affect the pollutants that are produced. But there is another parameter that I consider very powerful from especially the AQB, and is the fact that this is a kid-friendly device. So it's quite attractive and interactive and robust, so kids can play with them. And we have with this a unique opportunity to involve children in observations and practical citizen science from early ages, so they can see somehow what are the consequences of their daily habits, of the daily things that are happening around the house. They can actually, and this is one of the things we would like to do in future, they can actually take the AQB to other places and see how much the pollution is changing depending if they go to play in the park or if they go to school. So I think this is also very important because we can have the chance to, from early ages, create somehow an awareness and involvement of the people. And yes, of course, we have now devices that are easy to read, easy to understand. The more we can provide information that is not so complicated for the general population to understand, higher chances we have that they can actually use this information into daily decision making and support activities and changes that can improve their health and their well-being.
Very big, cool, a very big shout out there to get children involved in participant science. I couldn't agree more with that idea. They are our future generation, right? So even if we want them to take up the mantle from us, we have to inspire them now, you know. So a big congratulations on that work. I hope I get to see one of these sensors one day. I think that's we're gonna have to bring it to the final event. Actually, we're gonna be having the final event. I'm gonna do some marketing for that. But before we get to that, please, let's look at the questions that we have in the chat. We have one here for Andrea, so you get to continue here. Are your group working on implementing different kind of cooking activity setting on the monitor, like which of oil or frying, etc., to figure out which components come from, or do you think it's it blurs the picture too much during the data processing and could confuse people too much that don't use it or don't understand how to use it?
Yes, thank you for the question. So I actually believe that the more detailed information we ask, the lower is the chance that people will be engaged in the long term. So we need to keep a balance in between how much information we request and how much information we use for research. However, we can also engage people or like scientists, for example. This is something we have also done in Zagreb into our field campaigns. And we can have a closer follow-up of what are the specific activities and what are they actually cooking. So we had one of our EDIAQI partners, Marco. I'm not sure if he is in the webinar today, but with Marco, we could do a very interesting exercise where he was actually, we had a constant communication on, okay, I am cooking this today, I am doing this activity, and we could see changes in the peaks. There is another interesting feature from the AQB, and this device is integrating several types of sensors for particulate matter. So what we can also see is that depending on the type of sensor and depending on the type of activity, especially what type of cooking, like is it frying or is it baking, how the specific sensors respond to each specific type of cooking. So we can, and we are trying to do that, this is still going on, characterize more in detail how the different sensors respond to different activities. And if we can find ratios of response, we can more accurately say, okay, these conditions produces this signal, and these are different from these other conditions, and how much pollution is created from that. But yes, it's not easy to bring that to the general population, but of course we can, or we are trying to do it in some specific applications where we can have some scientists involved in the measurements.
Now I'm going to build on top of that because it actually worked out very nice for us, yeah, because there's now another question taking from what you said and bringing it to Ivan now. Ivan, any idea what may have caused those high benzene concentrations? So we've seen this kind of relation, right? Cooking, what you're cooking, how you're cooking it. So any idea what was behind the high benzene concentrations in all three schools?
Okay, yes, Alex. Usually the benzene concentration can also depend on the cleaning product that contain small amounts of benzene. Also, the aromatic compounds can be stay in the printer, laser, or in the printer present in the school.
So you think it's... Go, sorry.
No, sorry.
I was going to say, so you're thinking it's from the printer then? It's coming from the printer?
Yes, yes. Yes, usually the printer are present in the school.
I'm going to bring one comment from Carla that she mentioned, and I think this was in reference to the question, the second question of yours, Andrea, or the first question. These systems, I'm assuming it's the AQB, can be useful in enabling responsive management similar to water quality is monitored in swimming pools through routine measurements of pH and chlorine levels. A comparable approach is also applied to coastal bathing waters under schemes such as the Blue Flag program, where regular monitoring ensures safety and compliance. So if any comments to that, Andrea, and then maybe we'll go to asset for a second, just to see if this could be an example of a policy standard or of sort of a legislative approach. So any comments there, Andrea? Have you ever heard of this water program?
I haven't, so it's the first time I know about it, but I find it quite interesting and I appreciate the comment. Definitely, these devices can be very useful into regular monitoring that ensures safety and compliance, as you mentioned. We can actually also activate alarms or different ways of communication, so the people can actually see, maybe I'm not seeing the device, but I can get an alarm in my phone that's telling me that I need to ventilate or that I need to maybe change something in the activity I'm doing, and it's definitely a potential application, yes.
Asset?
Yeah, I think that's a good comparison, the Blue Flag program for monitoring beaches. And I would like to know, probably some of you already know of this. So the Energy Performance Building Directive, EPBD, was recast in 2024 May, and those aspects should come into effect the 29th of or 26th of May in this year. And so one of the suggestions, or like the biggest aspect, was that they give now equal weightage to the indoor environmental quality as the energy performance. So any changes that are made to improve the energy performance of the building should also take into consideration what impact they will have on the environmental quality. And one of the suggestions is that, like you have this BER, like building energy rating certificates that buildings will display. Like sometimes you enter a building and say that this is A rated or B rated, or like some rating of the building performance is given there. Similarly, there is a suggestion that you would have a display of the indoor environmental performance of a building as well. So you have continuous measurements and then you display that, okay, our CO2 levels are within this range, or PM levels are within this red, yellow range. So that they have not finalized what form it will take in. But there is this suggestion that it will come into effect, first of all, for public buildings, not for residential buildings at the moment, but for public buildings. So when you enter a building, you will get you're likely to get some information on how the building is performing, both in terms of energy as well as in terms of environmental quality.
Yeah, for example, you have to have like the energy certificate, like, and I think it's an obligation of how much energy you use, for example.
Yeah.
So I think that's a really cool, interesting way of looking at it. There is one more question for you about the changing behaviors. I'm not sure if you can answer that very quickly, Andrea, but did the devices like cause any behavioral changes to the occupants, to the building occupants?
So I can actually remember one specific case where we could see that it was a house with a family. They had kids and the parents were smoking inside the house. And we could see immediately after installing the device that the concentrations in particulate matter were quite high, which they didn't know because probably they are already used to that. And as we have been talking, we don't have a good capacity to censor air pollution as humans, right? Which is what Asit said. So it was nice for us to see that they could have the information. They were also surprised by the high levels, and they mentioned in that moment that they will try to change their behavior. Unfortunately, as we can see the real data, we observe that there were some changes, but still not enough to decrease the PM concentrations to a safe level, even though they know, well, they have kids, no? But what we are still needing to do, and this is something that is going to happen soon, we will prepare a report for each household so they can see actually the statistics and the data of their measurements compared with other households. So they can not only see their own data, but how this is comparable to other households in a way to create somehow of awareness. Okay, this is actually a problem and you should address it. But it's not up to us to say the people what they have to do. They have to make their own decisions. But yeah, let's say yes and no. And we need to work in better strategies, how to reach the people and how to make them more compromised with day-to-day decisions based on the data.
Very nuanced and look at that, and I'm happy that those family know that the smoking is bad indoors. I'm hoping that's good behavioral change for them. A really nice example. Okay, so last words from today in 10 words. Ivan, do you want to say anything in the closing? No more than 10 words. You got to do some good math as well.
No, I have nothing to do. Okay, for me, okay. Thank you, Alex. This is a very interesting webinar for me.
Asa, any 10 words?
Yeah, just say get involved and spread the awareness.
Andrea?
Visualization and engagement from early ages is important. I don't know if those are 10 words, maybe more, but
I'm terrible at doing the 10 words. I always get the math off. Okay, now marketing for today. We are going to be having our final event of the Ideal Cluster. Please join us. It's going to be in Brussels and also online. It will be taking place on the 9th of June. And you're all warmly invited to register and to join us. You'll get to hear more from me because I will be the master of ceremony for the day. So please do join us there. It should be a lot of fun. We'll be talking about a lot of different aspects, and the big aim here is to make a big policy impact on the day, with hopefully a lot of policymakers coming from Europe, because we'll be in Brussels and we can share with them all the data and all of the findings from our project. So please do join us for that. I hope you have your smartphones out because we always do this, some marketing. So please, we invite you to join the Ideal Cluster Project social networks for more seamless updates and information. So I'll leave this here for a second. Now you can join. We have so many different QR codes for you. You can join the EDIAQI project here. You can join our YouTube, LinkedIn, Facebook, Instagram, or even Mastodon and X, which we're not actually using too much at the moment, to be honest, the X, because of Elon Musk. But that's a whole other story. So send our heartfelt gratitude to you, our panelists, for your invaluable perspectives, and especially to you, our audience, for the engaging discussions that brought this event to life. With that, we conclude today's session. Until next time, stay connected and informed. I'm wishing you all excellent air quality, both outdoors and indoors. Thank you and goodbye. Thank you, everyone. Ciao.
Bye-bye. Thank you.
Thank you all.
Thank you.
Bye.